Nice to see you all. So I'll be briefly talking about impact of air pollution on agriculture sector. So over the last almost 3 days, you might have heard about these sources of air pollution, where the pollutants are coming, where they are going to, what are the likely impacts on different sectors, including public health, agriculture, and climate change, and also a lot of socioeconomic issues. So assuming that you are all well familiar with the different sources of air pollution, I'm not going into that. Just to give you a quick overview of agriculture sector in South Asia, when you put that in the global context. Yeah, putting the agriculture in South Asia in a global context, because I'll be primarily talking about how air pollution or different air pollutants affect the different crops, and what are the larger impacts in this sector in our region. So if you look at just 2 examples here, this is a quite recent data. For 2013 and 14, if you look at the global rice production, you see almost 25% of the global rice production comes from South Asia. And if you look at wheat, about 15% is coming from South Asia. There are a lot of other crops as well as food grains coming from South Asian region, rice, wheat, soybean, etc., etc. So in terms of South Asia's contribution to the global food, it's quite significant. But at the same time, you might have heard over the last few days that South Asia, particularly very vast Indo-Gangetic plain, is one of the highly polluted regions in the world. So we are in a position where Indo-Gangetic plain is kind of a food basket. At the same time, it's also one of the highly polluted regions in the world. So we are in that situation. Just to give you a brief overview, in a further plant, basically we consider 4 major things. It needs sunlight for photosynthesis, and it also needs air. It interacts with air. So basically carbon dioxide for photosynthesis. It doesn't only take carbon dioxide, whatever in the air, that will also interact with the plant. So basically different type of pollutants. And a medium, basically soil, water, nutrients. And there are other external factors. They will also influence plants development, like temperature, high temperature, low temperature, humidity, rain, flood, droughts, etc., etc. So primarily you can put them in 4 different categories. And if you look at the key air pollutants that are of interest from the agriculture point of view are ground level ozone. So most of the agriculture impact of air pollution is due to ozone in the ground level ozone, surface ozone. We're not talking about the stratospheric ozone up in the atmosphere. And then particulate matter. You might have heard about different forms of particulate matters, including black carbon. And then acidic compounds. You might have heard about acid rain. So there are some chemical species which are acidic in nature, and they affect, if they are in a good amount, they would also affect plant activities. Ammonia. Certain plants are sensitive to ammonia. And also nitrogen and phosphorus. When you use chemical fertilizers, some of the fertilizers we use that would simply evaporate into the atmosphere, and they will, after all, they will just get deposited either through dry deposition or the wet deposition through cloud, rain, fog, etc., and get into the soil and also interact with the plants. And I'm not sure if you have heard about eutrophication. When you have a lot of nutrients going into the water, and then you see a lot of different weeds growing. That's because of high amount of nutrition going into the water body. That is also connected to atmospheric cycle of these nutrients. And now, when you talk about bigger impacts, before going into the impact, you need to understand what are the effects, how air pollution affects plants. So there are basically two ways how air pollutant can interact with the plants. So first one is a direct impact, and the second one, indirect impact. Within the direct impact, the primary source of energy for plants is the sunlight. So when you have pollution in the atmosphere, that would interact with the incoming solar energy, and primarily there's a narrow band of solar energy that is utilized by the plants, what we call the photosynthetically active radiation power. So when the power is cut down, then that will affect plants' growth. And then deposition of the pollutants on the surface of the plant, either on the leaves or branches, that will also affect plants' development. Acid rain or acidification, they are primarily corroding. They damage the surface of the leaves. And the most important one is the damage due to ozone. Ozone is toxic to plants. So if you have ozone higher than certain amount, then plant would start getting injuries and they will not develop properly. And two indirect effects are through change in climatic conditions. So for example, if it's too hot or too dry or too wet, that would also affect the plant's activities indirectly. And also changes in the hydrological cycles. You might have heard over the last few days, the air pollutants are also interacting with the hydrological cycles, particularly black carbon, that interacts with our monsoon circulation and the precipitation pattern. So that is going to indirectly affect the plant activities. These are some of the visuals. A picture can tell a lot of things. So if you look at how dust gets deposited on the crop leaves, and also how and how ozone damages the surface of the spinach leaf. That's, for example, that's a spinach leaf. That is injury caused by the ozone exposure. And on the other hand, as I said earlier, the change in climatic conditions, either too high or too low, that's going to affect the plant's physiological development. And also, hydrological cycle as well as the availability of water for the plants are also affecting their development. So the major pollutant that causes the major damage in agriculture or in the plants is ozone. And that are some of the effects that ozone exerts on the plants are listed there. So basically from germination all the way through development of the plant and then development of the seeds and crops would be affected, and also that will also affect how plants absorb carbon from the atmosphere. Plants act as a carbon sink, so carbon is absorbed from the atmosphere and used for their development. So if the plants are not healthy, so that will also affect carbon sequestration. And they also get older earlier than expected. So if you look at that figure on the left side, clearly shows if you have a higher concentration of ozone, the productivity of the soybean, of different varieties of soybean, clearly goes down. So that's how it's going to impact the overall production of soybean and other crops. And these are some visuals. You can see 3 different varieties of tobacco plants, an experiment done in Lahore, and you see how they get, how different varieties of tobacco plants get affected by ozone exposure. Now going to a bigger regional scale, if you look at this figure, you'll see a lot of purple area here. Just look at the one within the blue circle. That's where South Asia, part of East Asia is. So this is for year 2000. It's a global distribution of surface ozone. And you see we are right there at the hot spot, ozone hot spots. And it's been projected that by 2030, South Asia would be the most ozone polluted region in the world. So we will have the highest surface ozone in the world by 2030. And to give you a kind of impression how ozone behaves throughout the year and also throughout the day, so if you look at this, the lower panel here, it shows crop cycle for some of the crops like wheat and rice and soybean in China and India, which part of the year we plant them, we harvest them, and how ozone behaves throughout the year. So ozone peak, you can see here, it peaks around March or March to May, where ozone is normally higher in the atmosphere. And then it coincides with wheat farming in India and China, and the lower ozone, and again it starts increasing. That also coincides with the part of soybean and rice farming. And it's not just across the months, across the season, but if you look at what happens over a day, if you look at this plot on your right upper corner here. This is a seasonal variation of ozone over day. When you like 3 or 4 months, you put them together and look at how the ozone varied throughout day. And that's what plotted here for different season. This data was collected in Kathmandu. And you see ozone gets higher in the afternoon. So from around 10 o'clock to 7 or 8 o'clock in the evening, it gets higher. It gets on this peak. And that is the time where plants will have highest activities in terms of photosynthesis. And then ozone also gets highest at that time. So their activities will be definitely impaired by ozone concentration. And one thing you might come across reading different articles or newspaper articles, that's called AOT4T. So it's nothing but how long the plant has been exposed or how many hours plant has been exposed to the ozone concentration higher than 40 part per billion. That's the unit we use. So basically, if ozone concentration goes higher than 40, then that is going to be more toxic to the plants. But how long it is exposed, so you multiply with the number of hours it's exposed, and then that parameter is used to assess agricultural impact of ozone. And now going to a bigger scale, this is what the ozone damage is. If you look at globally, about 110 million metric ton of 4 major crops. That doesn't include many other different crops. Just 4 major crops: wheat, rice, maize, and soybean. Globally, just because of ozone, 110 million metric ton of crop of the yield is lost because of ozone damage to the crops. And if you look at this, circles with the regional distribution, the Asia, South Asia, part of Middle East, and East Asia, that constitutes a big portion of that. And there was an analysis showing if we were to control air pollution, basically two air pollutants, one is black carbon, the other one is methane. Methane is a precursor for the ozone formation. So basically, if you have a methane in the atmosphere, it reacts with other species and forms ozone. So ozone is not emitted from any sources underground, or there is no primary source of ozone. It is formed in the atmosphere. When you have a sunlight, you have other chemical species, they come together, they cook, and then form ozone. And then methane is one of the precursors for ozone formation. So if we were to control methane and black carbon, so primarily we are controlling ozone and black carbon, then we will be able to save 52 million metric ton of crop damage annually and globally. And if you look at this table here, 5 countries that will benefit most from this kind of mitigation of air pollutant are, 3 of them are in South Asia and East Asia. So they contribute the biggest chunk. In other sense, they will get the most benefit of this mitigation effort. And so far I said, okay, how ozone is going to affect the plants physically, and then how it impacts in terms of crop loss or crop productivity. But at the same time, there is another factor that will also get into interaction, is the climate change. And the climate change, primarily we use a couple of factors. The change in climate that will affect the incoming solar radiation, and that will affect temperature changes, and that will also affect precipitation changes. So when you put air pollutant, primarily ozone and the particles, and the climatic factors like radiation, temperature, and then rainfall, there are many different factors interacting and affecting crop productivity. So when you put climate change and air pollution together in a very simple language. So this is a study done in India. So what we see here, without going into detail, if we look at this blue and black, if we were to control only air pollution, here it is referred to as ABCs, that's called atmospheric brown clouds. So if we were to reduce air pollution, so that's the blue curve, and if we were to reduce both air pollution and the greenhouse gases, so that would be the black curve. So what is shown here is if we had acted upon reducing air pollution and the greenhouse gases, so this would have been the rice production in India from 1960 to 2000. So in other sense, so that is the amount of rice production we have lost. So if we had controlled these two things, air pollution and the greenhouse gases, we would have actually gained that much of rice production in India. And then this study was further refined. There are a lot of factors, that what we call the co-founding factors, that confusing, what is causing what. So we need to filter out all those, confusing factors, co-founding factors. And last year this study got further refined, and you see here, without going into much detail, so this is this first panel is showing the cultivated area in India, and then this is basically reflecting the air pollution. We measure that in terms of aerosol optical depth, so loading of the particles in the atmosphere, and then what was the distribution of ozone across the region. So there are two different air pollutants, aerosol particles and the ozone. They were put in the model to simulate, and other climatic factors were also included. So here what we see for two different crops, wheat and rice. So this blue thing is the changes in production, or let's say loss in crop production because of climatic changes. And this yellow one is loss because of air pollution. So primarily ozone and the particles. So you see for different states in India, the loss ranges from anywhere from 5% to 80% or so. So if we didn't have pollution at all, or climate was favorable for those crops, we would have produced that much of wheat and rice more than what we actually produce. So that is the message here. So to summarize it, air pollution is a major factor for crop production globally. There are regional hotspots, and we are sitting in one of those hotspots, and that there are some numbers. But the key message here: ozone is the major air pollutant that damages crops, and you saw it goes all the way to 110 million metric ton or so. Particulate matter also affects, but not to the extent ozone does. But that's also something we should consider. And what is missing in the recent studies is the combined effect of air pollution and climate change. I just showed you two results here. They were mostly based on statistical models. They were not like a comprehensive crop simulation model. So that is partly missing in the research arena. And on top of that, what is particularly important is the extreme climate event and how the climate will change over next several decades. Climate will not change as smoothly as the climate models predict. And there will be ups and downs in precipitation, temperature, and other climatic parameters. So what happens if we have those extreme events combined with air pollution and that combined effect on agriculture? So that is a kind of frontline research activities at the moment. So that definitely needs further research and further understanding. And by now the agriculture sector is double hit by two different things: the air pollution in one side and the climate change on the other side. And we must consider these two factors when we are talking about air pollution, climate change, and agriculture interaction, how they interact with the agro ecosystem. And that, if we were to control or mitigate air pollution as well as the greenhouse gases, they must be done simultaneously. It's not like one is option for other. It's not like that. So we need to have both considered carefully so that they will result in optimal condition for agriculture. And on top of all, these issues, at least if I consider the situation in Nepal, where what I'm more familiar with, this air pollution effect on agriculture that hasn't been sensitized to the extent it needs to be. If you look at, I have down here a couple of additional slides for your benefit. You can look at, if you look at, who is going to benefit most out of this mitigation, efforts. Most of the South Asian countries like India, Pakistan, Nepal, Bangladesh, they will pop up. They get the largest benefit of this, and this hasn't been sensitized, through media and other means, and also this hasn't been considered seriously in the policy making process. So with that, I conclude a brief introduction to how air pollution affects climate, the agriculture. For your benefit, I listed down the major reports, global reports, regional reports, that put these issues in a kind of language that general public would also be able to understand, except the last one. Last one is a bit more scientific paper. Thank you.